Hello everyone, welcome to Enterprise Decoded, a technology podcast about the systems we build and the people those systems are built for. Hi, I am Anji Maram, and each month we will explore AI, data, platforms and automations and enterprise systems, not through the hype or buzzwords, but through intentional, empathetic and humble leadership. Here is the format. In every episode, we will cover the good, the bad, and the ugly. What's working, what's broken, and what we need to face head on. So today, we're talking about something that feels universal, but it is incredibly hard to engineer: the trust. Because trust isn't a brand message, it is a design decision, and it is an architecture decision. It's a product decision, and ultimately, it is a leadership decision. So let's start with the good. The good of designing for trust. To explore this with us today, I'm joined by someone who works closely with innovators and AI-first companies and entrepreneurs building the next generation AI-driven innovation. He is the founder and former CEO of Sierra Atlantic, a company he built for 17 years into global, the best-in-class services organization before it was acquired by Hitachi. Prior to that, he spent a decade at Intel. Today, Raju works closely with many founders and leadership teams, mentoring entrepreneurs as they build globally scalable companies, often from the early stages through the breakout growth. He also serves on multiple boards across technology and finance and social impact, including the companies like Eltropy, Seclor, and FalconX, as well as the organizations like RAND Corporation's Center for Asia Pacific Policy. Beyond that, he's deeply involved in building ecosystems as a co-founder of Kakatiya Sandbox, supporting long-term social impact, and an active member of Thai Silicon Valley. What makes Raju's perspective especially relevant is that he sits at the intersection of founders scaling from idea to real-world impact, and innovators building AI-first companies, and real operator experience, having built and scaled a company himself through acquisition. But more than all of that, Raju is known as deeply trusted leader in the Valley, someone people turn not just for expertise but also for judgment. And most importantly, I trust him to the core as a person, as a professional leader, and as a mentor. And that's exactly why conversation on trust feels so relevant. Mr. Raju, welcome to Enterprise Decoded.
Thank you so much, Anji. Real pleasure to be here with you this morning. And I appreciate your kind words, and also love the format that you guys have chosen.
Every organization today wants to build AI-enabled products. Some are rushing, some are experimenting, and some are scaling fast. But the biggest barrier isn't compute power, it is not data, it is not even the talent. It is trust. So my opening question is, why trust is a technical requirement more than any time in prior technology revolutions?
In traditional software, if you think about it, you can trace the logic. You can explain how you arrived at a particular outcome. In AI systems, in particular with the generative models, there is always a probabilistic behavior in that, right? So anytime you have an outcome that is built on top of a foundation of probability, even if the probability is very high of a certain event happening, so you need to explain why certain outcome has happened. You need to be able to monitor those outcomes, and humans have to rely on those systems now, right? And I think that's where the big sort of difference comes in. Perhaps one way to think about it is when there are truly life and death situations, truly mission critical, like say in the military setting or in a hospital setting, can you actually rely on the AI systems entirely? And if not, then how and where do the human beings need to come in, right? And the judgment, the human judgment that has to come in. So that's the reason why it becomes so important, and how you design this. And you cannot do that unless you design the systems with trust top of mind through the course of that work. Now it's all public information about Anthropic had with the department, with Pentagon, right? Question was not whether AI can actually process very complex amounts of data and come up with some recommendations or whatever that situation may be in a war setting. But the question was more about what kind of guardrails should it have, and at least from published information, what's out in the press, Anthropic refused to remove the guardrails, whereas the Pentagon wanted those to be, they wanted to have the freedom not to be limited by those guardrails. So that's an example of where perhaps you need to have sufficient human involvement. Again, in a hospital setting, there are multiple decisions that happen, and especially now with more of agentic solutions and automation starting to happen, right? Can you trust the AI systems to say take inputs from 5 different places, from your blood test, from your past history, from your family history, and then come up with a recommendation? Almost none of those should ever function without adequate human involvement, right? So it's a question of, can you explain the outcomes? Can you monitor the outcome? And can you make sure that there's enough human intervention at the right points? I think it's all those things that become important in when you're building solutions leveraging AI, because at the core, there is always an element of probability based on which you're making these decisions.
The way you put it is, it's a powerful distinction. AI just doesn't automate the tasks. It actually shapes the decisions in every organization in our day-to-day human life. And when you scale these decisions and you scale the consequences, the good news is that trust is not an abstract thing. Trust can be built. It is buildable. Mr. Raju, when you think about the trust as a technical requirement, what does that actually mean in practice when AI first systems are built?
Trust has to become a part of how you design the system. For instance, having audit logs of key AI decisions. So people can go back and see what decision was made and when, right? That kind of a thing. Or you should be able to explain the explainability of those decisions. Or monitoring bias. Sometimes bias kind of creeps in over time, depending on how the models themselves are built, right? Yeah. And there have been a lot of examples of those where that went wrong, and the bias kind of carried through, and something like fallback mechanisms. If the outcomes coming out of the AI systems are not what the enterprise decides is correct, there should be a fallback mechanism at that stage, right? So designing all those things, I think, and the human override paths, those sort of things can be thought about early on in the design and how you build the system, as opposed to that becoming an afterthought. Yeah.
Some of the mission critical decision making systems, even though trust is built, I think human being in the part of the decision making is a critical part of building trustable AI systems.
Trust is measurable through sort of 4 key categories as I think about it, right? One is the reliability of those solutions, and the explainability, and the fairness, which is perhaps the bias that comes into some of these AI systems. And the last is accountability. Who is accountable? You can't just say, oh, the AI system is giving me these answers and there has to be a human that's accountable for each of these sort of decisions that are coming out of the AI system.
I think I always take back you to some of the financial systems. The reason is we as a company do a lot of work in that and help a lot of CFO organizations for multiple enterprises. So when we first build some of these AI native solutions for CFO office, they first could not believe what they are seeing. So what we had to do was we had to really prove that the data and the results that are coming through AI systems are accurate compared to their traditional reports, traditional logical systems that they were using. And then we had to put explainability metrics in that. Whenever they are asking system to do something, whenever system is doing, we had to really explain how the decision is made, how the data is coming, and what objects literally it is looking, both at a functional business level and at the technical level. After building that traceability and then features into the system, then business users started trusting the system basically. So we had to really take that, some of those features that you mentioned, into the system as a design, core design. So that's one of the first thing that we took it as an architecture decision when we build these systems basically. So, but thanks for explaining that in a manner. I'm just giving it finance systems as one of the example because that's where we are good at. That's where we are experts at. I'm just taking you back to those examples again and again. Yeah.
No, I think it makes a lot of sense. Especially now with the sort of explosion of agentic AI, right? And if you think about it, let's say there is like 10 steps in a agentic AI solution, and each of those is operating at let's just say 95% accuracy. I mean, that seems pretty good if it's 95% correct. But when they start cascading, if every step is running at 95%, at the end of the 10th step, you're going to be right only about 55% of the time.
Yeah.
So almost half the time you'll actually get a wrong answer, even though each individual step is 95%. So that's the kind of thought process that has to go into designing these AI systems. As good, as powerful and all of that these systems have been and continue to only become much better, the errors can also cascade. The harm that comes from some of those errors, like we talked about, the decision that a CFO has to rely on, or even more scary in some ways in the military or hospital setting, right? The harm can also multiply pretty rapidly.
Yeah, agree.
If you don't pay attention.
In those three industries or three domains that we have taken, one is healthcare, one is military setting, another one is in the financial ecosystem. This is either answer should be 100% accurate or don't use systems. I mean, if it is anything less than 100% accuracy, that means these systems are not usable basically.
I think with all of these things, it's a question of how and when do you interject the human element into it, right? The human in the loop, so to say, right? And of course, a military general may not quite see his or her role, in the same way as a CFO's role. I understand the CFO's role is, relying on the AI systems is extremely important. But, in one case, life and death. In the other case, of course, it's very critical, enterprise decisions that happen.
In the examples that you have given, both in healthcare and then military and then financial domain, the trust is measurable through 4 categories. One is reliability, explainability, and fairness, and accountability. And most teams measure accuracy as the most important component when they build AI systems. But the accuracy without those 4 categories is exactly how you lose trust on the AI systems that are being built for. Now, we should talk about the painful reality of this whole AI systems. This section brings us to the bad. the section of this episode. Because most AI systems are not designed for trust upfront. They're actually designed for speed, and they are designed for innovation, and then they try to retrofit the trust into the systems. So, what do you see going wrong with that approach of retrofitting the trust after the systems are designed for something else?
Oh, okay. That's an interesting question. One of the things we need to be careful about is the adoption of AI is absolutely here, and it's growing very rapidly, right? There's no question about it. I see that from a lot of the AI first startups that I'm involved with, where they're scaling dramatically just in terms of actual, customers that are paying for their products, for their solutions and all of that. And I'm sure you see a lot of that with, Miru and Critical River and all that. But we should not confuse adoption with trust yet. One could say that, because so many people are using, millions of them are using, they do trust the systems. I don't think we are there yet in a lot of AI usage. Hallucinations absolutely have come down dramatically, no question about it. Something we used to talk about, we don't hear that as much now. A good example is the Amazon product internally that they were using for hiring, heavily dependent on AI, but the product was built, the model was built with existing data, which had a very high bias towards male applicants. So in fact, even when applicants, that had a woman in it or whatever, right, the AI system would actually shed those resumes. And it took them a while to discover that, that bias was not addressed for a long time. And then they stopped using that, or, then they started accounting for that bias to redesign that system. So there are countless other such examples, where unless trust is built, is engineered into the product right from day one, along the criteria that you talked about earlier, that we talked about, I think there's a real risk that the adoption will actually, stall at some point. Yeah.
Why does explainability matter so much in AI for systems that are being built?
Yeah. So for one, if you can't explain it, you can challenge it, right? And you can debug it, or as a result, the user cannot trust the system. And I think bias actually makes the problem even worse, because it often hides that high accuracy that you need to have, and those sort of biases propagate. The decision built on those biases, they propagate through the system. So often these models need to be tested for smaller subgroups, especially in the case of bias, and that's the only way you'll uncover these sort of hidden issues. If you can't test the subgroup behavior, right, you can't detect the harm that comes from it, and once harm happens, the trust evaporates. Then the scaling stops. I think that's the real challenge. These AI first solutions will have, unless all the elements that we talked about earlier relating to trust are designed into the system itself from day one.
Thanks for explaining the trust in the context of bias and opacity with the real-time example, and also summarizing that in a very powerful manner. Now we go to the ugly. AI systems can become unaccountable power. So can you throw some light on that?
Perhaps a good example of things getting really going haywire, and that led to a pretty serious financial issue for Zillow. You may have read about it, right? Zillow had this, AI system that was into flipping homes, AI algorithm that is driving the decisions on which properties to buy and flip. And the model was built on data that was just not keeping pace with how rapidly the market moved. As a result, I think they lost something like $600 million, something like that, and their stock was down 25%. And of course, they canned that project, right? So that's perhaps a good real-world example of things going real ugly when you start obeying AI so much and stop thinking about, how you're applying AI to your real-world problems.
So when all the AI lab companies that are training for the current or past data, so there is absolutely a lot of scenarios that data doesn't even exist. In the Zillow example, some of the market conditions were never existed, so the model was trained from the past data, and then it is making significant buying decisions without even some of the market scenarios that never existed. So that's why I believe I've heard even lab company CEOs are saying there is a tremendous amount of opportunity using the lab models, LLMs or SLMs that were already trained on the existing data, taking those and then training those to the context of the business, context of the domain, context of the business functions, and then making them really work and making them really trustable systems.
Yeah.
There is a tremendous amount of opportunity in building such an applications in coming months to years. That's what we see as a tremendous amount of opportunity. That's what, even our companies are primarily focusing more on using the training that is done by lab companies and taking that and then training that to a contextual engineering to the domains and the industries that we serve. But thanks for explaining with such a nice example where the trust was not built because the models were not trained with all the possible scenarios of the data.
Yeah. No, you're absolutely right. I think for a lot of these things, again, you might have a solution for, in general, say for finance and accounting, but there again, there are elements of how every company operates differently. Every public company has its own processes for finance and accounting and all of that. And I'm sure the way you are talking about it sounds like your solutions are architected where you might take something out of the standard LLMs, but there's a lot of context that's specific to that company that's embedded into how you're delivering your AI solutions. I think that makes absolute sense.
Yeah. I mean, that's where tremendous opportunity that we see ahead of the times.
Yeah.
Really appreciate you coming here. Here is what I'm taking away from this conversation. Trust is not a brand attribute. It's a system property. And responsible AI is not a compliance layer. It is an architecture. And bias and opacity don't just create harm, they block scale. And the ugly truth is, when AI becomes unchallengeable, it becomes unaccountable power. And maybe the simplest way to think about it is this: the most critical the decision, the less acceptable it is for AI to act alone. That is why trust must be treated as a technical requirement. It has to be accounted in architecture. To our listeners, thank you for joining us for the episode of Enterprise Decoded.
Thank you, Anji. Really enjoyed this conversation with you today.
Thank you, Mr. Raju. Until next time, let's get to work.